So, hi. So I'm going to talk a bit about what you can do to secure your web app in Azure today. So just background, my name is Franz Lutzen. I'm CTO, CISO, CFO, various other bits of a company out in Chalkgrove called New Orbit. We are an Azure Gold partner, but I'm not here to do the marketing thing. I'm going to give you the ugly as well as the pretty. A lot of the systems we host in Azure has a lot of very confidential data in it. So security is something we've worked really hard on for a very long time, to the point where, because of what we do, we meet with Microsoft security team about twice a year to talk about the new security features and those kind of things, to give them our honest feedback. And I think we have helped to shape at least some of the security features that are in Azure these days. So that's sort of the background to this. I also read a lot of pen tests. It's come to the point where I actually almost enjoy it, which makes me really sad. But yeah, so that's sort of the background to what I'm going to talk about today. So it's going to be really quick. I'm going to make it very demo heavy rather than PowerPoint heavy to try and show you stuff. But we're going to cover upwards of 10 different items, each of one which I could make into a full 1 hour talk. So I'm just going to go over it really quick. So don't expect to walk out of here knowing exactly how to do the bits. I'm hopefully just going to illustrate the concepts. Also, it takes quite a while to set some of these things up, so I'm not going to press the create button and then sit and make you guys wait for 5 minutes while it runs. So I've pre-created everything, so I just have to fudge that a little bit. And yeah, so I'm just going to give you an overview of what you may or may not know about. But before I start on the actual specifics, probably worth to talk a little bit about an approach to security, because a lot of people talk about just preventing attackers from coming in through the front door. And the reality is there's sort of many more layers to it than that. That's really only like step one. For starters, you need to think about internal attackers, whether they're witting or unwitting. So we know there's research that says about 25% of attacks involves an internal actor. I think that's woefully underestimated, and I think the reality is much, much higher in reality. Not necessarily because they're malicious, but because social engineering is much, much easier than hacking through the front door. It's much easier to call up customer service and say, hi, yeah, I forgot my password. Yeah, it's because I've been on honeymoon. Yeah, it was great, Barbados is great this time of year. And I changed my name as well, so can you just change my email address as well? And then my password, and bing, bing, right? That's what happens in the real world. It's not very many of these hackers with hoodies sitting there hacking away at stuff. It's so much easier just picking up the phone. And that's the reality of it. So you've got to think about, how can you protect yourself from people in your organization that are trying to be nice, right? And that really is one of your biggest security threats. So when you think prevent, you've got to think both external but also internal. How do you prevent internal people from doing stuff they shouldn't do? You also got to think, and this is where most people don't go to the next step, how can you detect that something is going on? Because it's great that you put all of these firewalls up, right, and all these big walls and stuff, but how do you know somebody's trying to climb over the wall? Or has already climbed over the wall? And if you don't know, then chances are somebody will do it and they will be in there and you won't know until it's too late. Sometimes we hear about breaches months or even years after they happened because nobody detected it. So you've got to try and find a way of detecting stuff. So I'm not going to talk a lot about detection today. I'm just going to point you to a couple of resources right at the end. And then finally, mitigation. You need to start thinking about when you get breached, not if, but when, because it does happen. What are you going to do about it? And there's active and passive mitigation. So passive mitigation is the things about, okay, so I'm going to imagine people are going to come in. How can I make it harder for them to go further? So that might be you encrypt some data in a way that, so it might be an attacker can get onto your web server, but they can't go any further, or they might get into your database, but they can't read the data. Those kind of passive mitigations. And depending on your security exposure, there are lots of ways you can do that, including putting more layers in your application. You can have, if you have a really highly secure application, like I was looking at one for a company that provides the kind of services where celebrities recruit them to go and basically send armed guards in to pull them out of trouble spots, that kind of stuff. And they were storing the travel plans for these people in their database with the name right next to it. So it would literally say, Beyonce is going to be in Nairobi on this date at this restaurant at this time. That's a really bad idea, right? You might want to partition your database. You might want to have extra layers in different servers that are talking to the database, separate from the app servers and that kind of stuff. But it depends on your exposure, right? There's no such thing as 100% secure. It fully depends on what's your risk, right? because you can't be 100% secure. So you've got to just adjust this against how much does it matter if you get breached, and then have an appropriate security. Because also if a state actor wants to get into your system, they're going to get in. I don't care what you do, they're going to get in. The British government broke into I think it was a Belgian bank, by breaking into a bank worker's flat and installing malware on his laptop. So, if you have access to those kind of resources, they're going to get in, okay? So, you just got to think about your security posture and then think about these levels of approach. So, I'm primarily going to talk about prevention today and a little bit about passive mitigation. All right. So, last time I counted, there's 6 different ways to host a website in Azure. I think most people use web apps or app services or whatever they call it this week. So that's what we're going to look at today. We're going to use Azure SQL and some blob storage. I do use Cosmos DB a lot because I like it and it's fantastic. But if you are in a high security environment, a high compliance environment, Azure SQL is definitely the tool to use. It has got a really vast array of security and compliance features that you can tap into. Cosmos DB is great and secure and all of that, but it doesn't have all of those compliance tools. So when your auditors come knocking, if you're in that kind of environment, you're much better off on Azure SQL. Okay, you can tick a lot more boxes with Azure SQL out of the box. It's just one of those things. I'm not sure that it is more secure in reality, but then there's InfoSec and then there's security, right? Interestingly enough, there's a lot you cannot do with app services, but the documentation does not make it clear. So one of the things I'm going to tell you today is the things that you might want to do or think you can do, but you can't. So at least I'll save you some time in trying to make it work and then realizing you can't. And that's because there are things that only apply to VMs and that kind of stuff. But then again, you get a lot out of the box, like the Equifax breach last summer, 154 million records, because they hadn't patched their servers. Really banal. If you'd been on Azure App Services, that couldn't have happened because they get patched for you, right? It's really simple stuff like that, right? So, it's sort of swings and roundabouts with that. Okay, so prevent. Firstly, you got to actually do the hard work yourself of actually trying to fix your app code, right? So Troy Hunt has some great courses that are worth watching. I find one of the best things you can do is have mandatory code reviews. So if you use GitHub pull requests, if you don't do it, because it's surprising how many subtle bugs get caught in a code review when you just have another pair of eyes on it. And you can set up GitHub to require that you can't check in stuff without a mandatory code review by somebody else. It doesn't have to be a senior person, it can just be peer reviews. And that to be honest, if you can do one thing to improve security, that's a really good starting point. Do all the little things like, so if you go and if you read any pen test that's done on a site for somebody who hasn't done one before, there is about 10 things that always come back every single time, right? They're not particularly high security stuff, but it's like, you're sending down the ASP.NET version you're using on the server and stuff like that. Just get rid of those, mainly because it's just embarrassing when they turn up in the pen test report, and the pen tester sees those things and he says they don't know what they're doing, and they start digging even harder, right? So most of the time, pen tests are done by your customers, and it does look bad when they come back with 20 or 25 findings, half of which don't matter, but you could have knocked them off in an afternoon, right? So just worth doing those things, and they're easy enough to find. And finally, consider using, this is again an app level thing, using Azure AD B2B or B2C. So what that means is, B2B is the Office 365 logins. If your customer is using Office 365 or similar kind of scenarios, consider using that login instead of doing login yourself. Or B2C is basically hosted identity management by Microsoft. So you can basically say, you can send them over to Microsoft to do the login, and then they come back to you saying, it's this user. So that means Microsoft handle all the password storage, hashing, the login, and they apply some lovely machine learning so that if all of a sudden you log in from Russia and you don't normally log in from Russia, they will sort of prompt you and say, that's a bit weird, and are you sure about that? And those kind of things. So it's just a way of outsourcing that. I mean, I was until quite recently skeptical, but I've just launched 3 projects all using it, and it's actually really good. So it takes a little bit of letting go of that, but you know what? I'm actually really pleased I don't have to do it anymore. So it's one less thing to worry about. Okay, there's one thing you should do in your application. So you've set up your thing on Azure. So this is, can you see that? No, you can't because it's on the wrong screen. There we go. Nope, that was definitely wrong. There we go. There we go, see? So, first thing to do when you are up on Azure is just to, oh crap. There we go. First thing to do is, so you put this thing into your app service, right? Nice and easy. And so first thing to do, very banal, but definitely worth doing, is to just go into your application settings. Here. And just switch off the stuff you don't need. So by default, PHP is on your server. Well, you probably don't need PHP, so just get rid of it, because that's a security vulnerability right there, right? If you look at some of the app services that were created a little while ago, you will find that some of these other things were also switched on by default. So just go in there, switch them off. Really simple thing to do, but it just improves your security posture straight away, right? Okay. So, I think that was it. Can I? Yes, I can. That works great. All right. Okay, so use SSL. This is one of the ones where I think Azure is really missing a trick. They have put commercial interest over making it easy for customers. So you can use SSL on Azure. Firstly, it's a premium feature. You can't do it on the cheaper service plans. It's brilliant, right? You have to go to the premium ones to use SSL. More importantly, it's not free to use SSL. Hosting is costing money and it's not free to get a certificate. So you can buy your cert and upload it. If you do that, D and Simple, for some crazy reason, have a reseller deal with Comodo where they sell the certificates vastly cheaper through D and Simple than you can buy them from Comodo. I don't know why, but you can literally save hundreds of dollars on a certificate. So that's worth doing. Azure does have a baked-in cert mechanism. There is a way in your Azure App Service to just tick a box and say Azure handle it for me, but they're not exactly cheap. So, if you don't want to spend it, it's like a few £100 a year kind of thing. So, if you want to do that, that's great. You can use Cloudflare. They do have a free service where up to a certain size, they will provide SSL for free for you in front of your thing. And that gives you some other benefits as well. Troy Hunt swears by it. Or you can use Let's Encrypt, and I'll show you that in a minute, how to do that. It's not officially supported by Azure, but there are ways you can do it, and I'll show you. And then set up SSL redirects. So just worth mentioning. So this thing about where you go onto your website and then it redirects to SSL? So it's always worth doing that. It's just, and there even is a tick box in Azure you can just tick to say always use SSL, and they will sort of do that for you. The problem is using the Azure one is problematic because it disables things like app initialization and the keep alive, keep warm thing that they have on Azure. They no longer work if you tick that box. So you probably want to use it in using web config if you're doing .NET stuff, and you can set up SSL redirect rules in there, but there's certain exceptions you have to set up. It's unfortunately a lot more complicated than it should be. If you're doing it in code itself, you're probably fine because things tends to then get through to you. So if you're doing it in with the require SSL headers or any of those kind of things, you're fine. That works fine. It's as soon as you try and move up a level, things get really complicated really quick. Okay. I will probably write a blog post on how to make that easier, but just be aware that it's not as simple as it looks, sadly. Okay, so let's encrypt. It's a bit tricky to get up, but once it's up and running, it's free. I don't particularly like it, and I'll show you why, because you end up storing a password in free text, a very powerful password in the wrong place. But I'll show you how to do it. So, basically, the first thing we have to do is create what's called a service principal. Does anybody here know what a service principal is? So one person. So a service principal is a very fancy word or phrase for a user that is not a human being. It's just an application user. That's all it is. So we have to create a service principal, which is just an application user, and then we have to give that user access to our Azure subscriptions to do certificate stuff, and then we can install an extension that on our website that will log in as that user and sort out our certificates for us and give us free certificates from Let's Encrypt. Okay? So it's a bit convoluted, unfortunately, and the documentation is not great. But if I show you, where's my mouse gone? Oh, there it is. Okay, so let's just do this quickly. So we are going to enter Azure Active Directory. Yep, that's fine, I don't care. And then we go into app registrations, because that's, when I say service principal, you look for app registrations, right? easy to remember. And you can click on that. You can see I've created a few already. And then you create a new application registration, and you can call it, demo, whatever. And you say that it's a web app, and you give it a URL, which can just be localhost. And then you press create. Oh, you have to tab out of the field. That's inconsistent UI. Lovely. And that creates a service principal, which is a user that is not a human being. That's intuitive, right? You all got that? You would have figured that out, right? Good. Right. Anyway, what you then do, so you note down this application ID. That's your username. Okay? It's not the object ID, it's the application ID. Again, very intuitive, so just remember that. And then you go into settings, and you create a key, which is a password, by the way, in case you wondered. Also known as a secret in other places, depending on where you look. You create one, give it a name, give it a duration, whatever, and then save it. And then you get, that's your password there, called key, or client secret, depending on where you look. You got all that so far? Okay, cool, brilliant. So, as I said, it isn't as bad as all that, but if you look on the internet for how to do it, it tends to be even worse because they insist on using PowerShell for it all, and that only makes it even more confusing. So, what you do then is you go back to your application. Here we go. And go in here. And then we go down to Advanced Tools. Here we go. And which is a great UI, because then you get to press go here. It's great. At least before, you used to be able to remember that it was .scm. That used to not be linked to. You had to go and type that URL in. So, anywho, what you then do is have a look at this thing called Site Extensions, and look at the gallery. Now, top tip for you when you're in here, by the way, don't press Enter in the search box, because the Enter is keys to something else, and it takes you back to the installed page. It's fine. We don't mind much. Anyway, so what you have is you have these three different versions of Let's Encrypt. All right. The one we want is one of these two on the left, and you either need a 64-bit version or 32-bit version, depending on what your web app is set up to do. So I've used 64 for this. Now, this also only works if you have web jobs in your app service plan. So for the most basic app service plans, you can't do this either. Okay, so it'll only work for like production sites, not for test sites, really. And this is where it comes in. So what you basically do is you have to go through and fill all this in. So the subscription ID should be easy to find. This client ID, that's the application ID of our service principal, which is an app registration. And the client secret, that's the key we did, which is the password. And then you fill in the rest of it, and it's, try a few times and it ends up tending to work. And then it just tells you stuff that doesn't matter, and then you can go to the next page. And then you select, and this is where it gets really nice. You select the domain you want, or domains you want, so assuming you've already set up some domains to point to your site, press the requested install certificate, and 7 or 8 times of 10 it goes through the first time, and the other times you press it again, and eventually it works. You end up getting a yellow screen of death normally, but, well, in about a third of the cases, but then it eventually works. And then, when you come back to your website, what you will find is that under the, where were we going? Oh, it's different resolution if I can't find anything all of a sudden. Here we go, it's SSL settings. Okay, I'm way behind schedule. I'm going to have to speed up on the other bit. Okay. Okay, doesn't matter. So what you'll see in here is that you have a certificate and it gets automatically bound. And what will happen is Let's Encrypt certificates only get issued for 3 months at a time, which is a much better way of doing it. But that little extension we installed will sit in the background and it will automatically renew your certificate every few months. So that's taken care of. Now you have SSL for free forever. So it's a bit of a pain to set up, but then it works. The problem is that those secrets we put in, they are literally stored in application settings in the app. So anybody with access to the app can go in and read those passwords. And if they can then use those to log into stuff. Oh, because what I didn't show you is I had to give this our service principal owner rights to the subscription, so that user can do anything. If the documentation says you don't have to do that, I can't get it to work without doing that. So, it's one of those things, right? I'm not sure I would really recommend it, but it does work for SSL at least. Okay, moving on. Virus scanning, you're out of luck. The documentation is very misleading. It says that there's virus scanners installed on app services. It's not true. There's virus scanners installed on the underlying infrastructure. The actual OS that your app runs in does not have a virus scanner installed in it. So you can stick a virus-infected file into your app and store it on disk in your app, and it will not be picked up. Okay. It also means you can't use things like the MC API to virus scan anything that gets uploaded. So it's, you know, that's not a nice thing, really. And I don't have a good answer for it, other than spinning up a VM and putting some virus scan on that, and then set up a service on that, and then. But the point is, you wanted an app service to make life easy, right? So they did say a couple of years ago they were considering putting virus scanning into blob storage, but they haven't done that yet. So I don't know if they ever will. Okay, moving on. Who has heard of a web application firewall or a WAF? You have. Okay, they are. I'm really not keen on them. The idea is that you stick a proxy in front of your application, and all the requests that comes in goes through that, and that WAF will then analyze it and say, oh, that looks like you're trying to do a SQL injection attack or a cross-site scripting attack or whatever, and then it stops it from getting through to your app. Now, I think they have a use. They can be used when say you might have some legacy code that you're not trusting or whatever. I think the danger, or they might be used as an extra layer of security. The danger is if you think you can use it instead of making your application secure. And that's a really, really bad idea. So it's one of those things, it's a little bit like a false sense of security. You know, it's this thing about, if you look at it from a epidemiology point of view, bike helmets causes more danger than not having bike helmets. If you look at it at a, you know, at a population level, it's a little bit like that. So I just want to be careful with it, but what I would say is whatever you do not use Azure's WAF, okay? Don't. I've just spent a month and thousands of pounds figuring out that it is absolutely unusable, okay? So don't do that. It probably will eventually get good, but right now it's clearly they needed to tick in a box to say they have one. They brought some open source software in and shoved it on some cloud services, and it's appalling, okay? Absolutely appalling. The performance overhead we measured was like in the region of 7 to 10 times slower. And they ended up saying we needed more WAF servers than we had web servers. This is just crazy, right? So we've dropped that. Encapsula works really well. It's a really good thing, minimum performance overhead. It works with everything except if you use the traffic manager on Azure. They don't like that. But if you don't use that, you're fine with Encapsula. Just be aware of the caching, because I had a system down for 2 hours this afternoon with a few hundred users unable to use it because Encapsula decided to serve up the wrong version of JavaScript files, despite us having cache busting on our files, because they cache a bit aggressively. So, you know, but apart from that, they're really good. We like them. Yeah, just beware of their caching. Okay. Now, this is one of those interesting things. I won't show you all the details of this. So VNets. Anybody have heard of VNets in Azure? So they are a great idea. So the thing is that if you go and look at your storage account or your SQL account or your Cosmos account, what you will see, in fact, I'll show you. I will show you this. I'll just show you one of them very quickly. So let's take our SQL servers, because it's right there and I can find it. Here we go. So what you will see if you go to firewalls and virtual networks, you will see that it says here, allow access to Azure services. And then there's a firewall setting down here. And this is great, because what you can do is you can control what IP addresses can access the thing. And I've just added the IP address for this venue here, so I can actually log into my SQL server in a minute and show you something. And that's great, but that little thing there, that means that anything in Azure can access your SQL server. And I mean anything. So if I want to hack your SQL server, all I have to do is stick a VM up on Azure, and then I just have to guess your password. So, you know, now, clearly there's obviously security about that. That's not as bad as it sounds, but you're really not in any way of isolating. What VNets can do, you can say, I don't want to do that. I want to switch that off. I'm not going to do it right now because it'll kill my demo later. And then you can go down here and say, I want to add a virtual network. What a virtual network is, it's basically a private network with a private IP address range inside of the Azure thing. So you can put your SQL Server inside of that, and you can put your storage account inside of that. You can't yet put Cosmos DB in there, but I expect that's coming. And therefore, all of a sudden, only the servers that you give access to have access to those SQL in your storage. And that's great, right? And if you have a VM, you can add that VM to this VNet, and then the VM can access your storage account in your SQL, and that's fantastic. Except it doesn't work with app services. Great. Really funny, you go into app services, and there is a way of adding an app service to a VNet, but it doesn't work with this. Great, you just get a 403 error if you try and access your storage account. So that's a shame. You can do it by using something called an app service environment, which is basically you hosting, rather than really using an app service, it's basically you buying some VMs and putting the app service infrastructure on top of that. So then you can do it. But that's a much, much bigger investment. It's much more expensive and it's much more infrastructure to look after. So in short, if you're running on an app service like most of us like to do, and I run some pretty big systems on app services because they're damn fine, then you can't use the VNets, unfortunately. Great shame, but there we are. Okay. Okay. Oh, need to click the right box. There we go. Azure Key Vault. So, who has heard of Azure Key Vault? Ding, ding, ding. Okay, so Azure Key Vault is an Amazon AWS as a similar kind of thing. They are a way of, it's a service that basically allows you to outsource a whole bunch of your security stuff. So they allow you to do things like storing secrets. So your database passwords, your database connection strings, all of those secret things you can put in Key Vault. And rather than having them in your application settings, because if you have them in your application settings in Azure, or even in your source code, somebody forbid, then if you put them in Key Vault, you have much more fine-grained control of who can access these secrets. So one of the problems you have with your internal stuff is you really don't want your developers or your ops people, in fact, any human being, to be able to log into your database with the same credentials as the application. Because as soon as somebody can do that, as soon as anybody knows the database credentials, then your auditing isn't worth anything, and your alerts aren't worth anything. So you need to make sure that only the application can log in as the applications. And one of the things you can do there is put those secrets into Key Vault, and then only give the application the right to read those secrets out of the Key Vault. And that way, no human being can, by accident or maliciously, go and log in as the app. They can only go into the database or storage if they are logging in as themselves as a personal user account. And that's a really important thing. And that's why it's a good idea to go through the hassle of setting this up. So, it also does a bunch of other encryption features, which we'll use in a bit. And also you can make it harder for attackers, blah, blah, blah. So of course the next problem comes, but hang on, what about the password for the Key Vault, right? That's really annoying, right? So this is where Azure has done, and I do think this is absolute genius. They have introduced something called a managed service identity. And what it basically is you remember that service principal we created before? So I will show you how to do it. You can basically tell Azure to create a service principal for your app service. And then there is a smart way I'll show you that you can say to Azure, please give me a login token for that user that you created for me. And you can only do that when you're running in the app service. And then you use that to log into Key Vault. And that means you've broken this chain of, surely there needs to be a password somewhere, you can get rid of that. And that's really powerful. So, I'm going to demo that. And that's, I'm going to just show you this. And I love this. That's the estimated pricing for Azure, for Key Vault. 2 pence a month. I think I can just about live with that. So, there's some transaction pricing, but it's, it's one of those things, it costs you hardly anything. All right. I just need to get my notes, sorry guys. All right. So the first thing we're going to do, we're going to switch back over to our Azure application thing. So this is my application still. So I'm going to scroll down. Oh, up. Where are we? Oh, hang on. Dig. Let's just search for it. Oh no, we're in the wrong place. That was the database, right? I don't want the database. I want the application. Here we go. So let's pop into the application here. Okay. So I'm going to scroll down, Managed Service Identity. And I just switch that on. When I do that, switch it on and save it, that then creates one of those application registrations automatically for me in the local AD. so I don't have to do it manually, and it's now tied to that application. I can then go and have a look at my Key Vault. So I've created a Key Vault. I pre-created one for you. They're easy enough to create. So I created one already for this talk. And I have this thing down here called access policies. And I'll just show you what happens when I add a new one before. So if I add a new one, I can select the principal. And if I then talk, I called that Flutzen, didn't I? So what you will find, you see this thing here? That's my application. So I can now give my application rights to talk to Key Vault. Everybody with me so far? Yeah, cool. So let's just go back from that because I have already done that. I'm very, very Blue Peter today. All right, so I've done one here. So I created this thing, Flutzen Security Talk, has the permission to do only two things. It can get secrets and it can list secrets. Those are the only two permissions I need to give it. And that means that my application can log into Key Vault and say, give me a list of secrets and give me the contents of those secrets. Okay? So what I've also done while we're here, I have added a secret. Very secret. I've created one called storage connection string, and I've created another one called dummy, which I will show you. So dummy basically has a value, which I can have a look at. It's quite clever. You can sort of put new values, and so it says super secret value from Key Vault here, right? Yay. Okay. So again, I can see that because I've given myself permissions to read it. If I didn't have read permissions, I could give myself write but not read permissions, which is quite neat. So it's like a write once kind of thing. Okay. Right. So how am I going to use that in my code? Right, so let's look at some code now. All right. Let's just close it. Shift Alt Enter, is it? No. Hang on. Yeah, it's a bit better. All right. Go back to that. Right. So we need some NuGet packages first of all. So we don't need that yet. So this is the web thing we're looking at. So in the web, basically what I want to do is I want to put my storage connection string, my connection to blob storage into Key Vault and then read it from there instead of putting in my normal app config settings. So what I'm going to do now is I'm going to tell my web application how to go and get that config out of Azure. It's actually surprisingly easy once you get to this point. It's like the half a day you spend reading about it to understand it all, and then actually putting the code in is really quick at the end of it. So what you want to do is you want to stick a couple of NuGet packages in. Let's get rid of that. So you need the you need the Key Vault package, and the I think that's actually the only one. Sorry, I've made notes. You know what happens when you get to my age? You can't read anymore. Yes, and you also need this thing here called app authentication. So app authentication is what allows me to talk to the managed service identity, you know, this magic user that they created for me. And the Key Vault is what allows me to use the Key Vault thing. So in my code, so how many are you using SPNet Core? Okay, it's a few of you. So in SPNet Core, they have a new configuration system. Now the principles, you can relatively easily translate the principles. I'm just going to show you how it works with that security setup. So in my startup, this is all I do. So I have this. So the way it works in SPNet Core is you have this concept of a configuration builder, and you say, okay, here's a configuration builder, and add a JSON file, and add another JSON file, and add some user secrets, which is a local development feature, and add some environment variables, which is the one you use to get to the app settings in Azure. But the key thing is this. I'm adding this line down here that says, okay, I want to add Azure Key Vault, and this is the Key Vault address, and this Key Vault object which I've created, I'll show you up here in a minute, and that. And literally this one line here will then tell Azure that whenever this web app starts up, go up to Key Vault, list all of the secrets that are recorded, and just shove them straight into config. And that's really all there is to it. It's that simple. And then everything that I've stored in there is then available in my application. And my application, the rest of it doesn't have to worry about whether it's in Key Vault or somewhere else. That's just all there is to it. So, and this is the other thing. So what I have to do is this Key Vault client here I have to create with, and it's basically just saying Key Vault token callback, which is that thing there. It's you say that line there, give me one of these token providers, then set this Key Vault up, and then wire that into the thing. It's 3 lines of code, and that is all it is, and the rest just happens magically. So that's pretty neat. I quite like that. So what you can see is if I go to my home controller, no, not there at the moment. Okay, so I have a little, so I just get my this.configuration.dummy. So you remember I put a secret in called dummy? Remember that? Saw that in Key Vault? So that will basically just read that value out of my configuration, stick it in the view model, and stick it on the thing. So if I go to my web page, actual web page, where is it? Ding, ding, there. Okay, here we go. So you can see here, if I just refresh that. So that's basically super secret value from Key Vault. That read that out of Key Vault and showed it there. And I don't think we have time. I could go and change it and switch it back. I won't bore you with that. So does that all? So that's one of the ways you can then get rid of your configurations and just put them into Key Vault instead. And that means now you don't have these passwords floating around. You don't have that security vulnerability lying there. All right. All right. So moving on. So the other really nice thing about Azure SQL is really neat in that you can actually connect with AD users. So you can also, and I will show you right at the end, how to connect your AD users onto Azure SQL. But because the service principal is an AD user, in principle, you can set it up so that you can connect to your Azure SQL with your managed service identity. And that means you're not even having to store any connection string or any real SQL users at all. You literally log into SQL with that managed service identity. Which means, and since there's no real password for it, and since you can only get an access token on the app, you have now completely eliminated the possibility that anybody would be able to log in as the app with the same credentials as the app. It's just not possible anymore. And that, again, means for your auditing purposes, that really helps. The problem is, if you like to use Entity Framework, you're out of luck for the time being. Well, it's not strictly true. You can just about make it work. I've included some links, and I'll stick if you really want to try it, do it. But you end up having to create your own SQL connection and pass them to Entity Framework. And that might be fine, or you might have messed with connection pools and stuff. I have no idea, and somebody who knows that better than me can probably figure it out. I daren't do it. It looks too scary to me. So for the time being, if you're using SQL ADO directly, you're fine. You can just, this is actually quite easy to do, relatively. If you're using Entity Framework, I'd hold off for 6 to 12 months before I try to do it, and just store a connection string in Key Vault for the time being. Okay. It's one of those things, they sort of dangle this in front of you. It's like, oh, well, I want that, and then you can't have it. Very sad. Anyway. Okay, so this subject here, encrypting data at rest. So there's a couple of things with that. So have you ever had one of those security questionnaires where it's like, oh, is your data encrypted at rest? What they mean by that is, so your SQL database, where it sits on the disk, is that encrypted? Or your blob storage, when it sits on the disk, is that encrypted, right? And if you know how Azure really works, you know that's a silly, silly question, but the auditors won't stop asking it. And it's silly because I've been on the tour of the Dublin data center, and it's basically 4 IKEAs blocked together and full of servers that are all unlabeled. And the only people who, the people who know what's on which servers work in Manchester. And they're not allowed to come anywhere near Dublin. And everything you have is striped over about 10 disks, spread over that 4 IKEA stores. So if you want to go and rip my hard drive out with my database so that this encryption matters, good luck, right? So, but auditors insist on it. So what you want to be able to say is everything is encrypted on disk. Now the good news is, you can now do that, have been able to for a few years. If you have an old, to show you, because it didn't used to always be switched on by default. So quickly to show you, if you go into your SQL database, let's take this one here, and you go down to encryption, and I just encourage you to do this if you haven't done it already. Transparent data encryption you're looking for, where are you? There we go. It's on by default now. Anything you create now, they have already switched it on. If you have an older database, you might need to just go in and tick that box. As I said, In real security terms, it's utterly pointless, but from when auditors come knocking, it's a good idea. All right? There's a similar one on storage, except you can't switch it off anymore. They just enforce it on now. But only, and that's important, only on storage account under about 2 years old. If you have storage accounts from before that, you can't even switch it on. You have to actually migrate all of your data to a completely new storage account. At least that was the way the last time I checked. So, just be mindful of that. Cosmos DB doesn't put any of this in the UI, but they are now encrypted at rest. They didn't used to be, but they are now. But they don't tell you anyway. It's just what they do. Okay, so that's really all there is to say about that. The other thing that's worth doing is to require secure transport. So that is meaning requiring that even within data center, just forcing all of your connections to use SSL or TLS for talking to storage, talking to SQL. Now, you can, in storage, it's a tick box. I would just encourage you to switch it on. It's not on by default. Where are we? Storage, here we go. So if you go into your, here we go, configuration. And you see down here, you basically set that to enabled. Okay? And then that means that anybody tries to connect with only HTTP will be rejected. So you're now enforcing SSL. It's just a simple little thing. On SQL, there isn't an equivalent setting, but if you switch on auditing, it will be enforced because of the auditing. So one of those things. So yeah, you can only do it indirectly. All right. Rushing through this. Okay. So this is pretty cool, and I do want to just show you this properly. So we talked about encryption at rest. So now the problem is, of course, so I have some sensitive data in my database. I might have, I don't know, an NI number, okay? And I would like to, so the problem is my support team have access to my database for support reasons, but then can now go in and read those NI numbers. Or if an attacker gets in and get access to my database, they can read the NI numbers. So what I'd like to do is encrypt those NI numbers in the database. Now, you can write a lot of code yourself, but actually there's this thing called always encrypted, where you can basically hand the whole thing over to a combination of the SQL security, so the SQL client in your .NET client and some Azure stuff on your other end, and they will basically magically encrypt everything for you, and I'll show you how to do that, and it's pretty neat. It unfortunately does not work with .NET Core yet, so I've had to do, for my demo here, I'm going to use a console app, which is the full .NET framework, just to show you. There are a few limitations, like code migrations, if you're using code first, might need a bit of help to deal with a few things, and there's certain things you can't do. For example, depending on if you encrypt things, you can't sort by the encrypted data, because in the database has no idea what the data is, so it can't sort by it. But depending on the encryption settings, you might still be able to select on it, as long as you select on the whole thing, and I'll show you how you choose those kind of things. So you're just going to be mindful that what you don't want to do is encrypt the data that you need to search and query and filter and aggregate on. What you do want to do is encrypt things like note fields and NI numbers and those kind of things. Does that make sense? And you can do something similar with storage, which I'll show you very quickly as well. So, okay. So what we're going to do is create another, hang on, bear with me. I need to get to the right pages. Okay, here we go. Right. So what we're going to do is we're going to go into SQL first. So you do need to connect with this thing here, SQL Server Management Studio. So I've connected up to my server, and I'm going to actually use this database here for the demo, but to give you, because I've already done it on this one, I'm just going to show you the wizard on the other one, okay? And then I'll just stop and we'll switch to the other database. So what we'll do is we'll go in here and we'll just right click on the table, and then we will do encrypt columns. Right, that's great. See if I can, oh crap. That's fun, yay. Okay, that works, there we go. Okay, next. And then we can basically say, I'm going to encrypt the name. the name one, and this is where we then get into this thing called encryption types. Now, we can talk, if anybody's into cryptography, we can talk a lot about what that means. But basically, you can choose between two modes. Either that every time you encrypt a string, you get a different value, or every time you encrypt a string, you get the same value. If you use the randomized, it's obviously more secure, but that means you can't do any searching or joining on it, because the client has to be able to predict what is the encrypted version of the text you're putting in. If you make it deterministic, then you can search and query on it. Okay, so basically, randomized means you can only retrieve it, you can't query on it at all, whereas deterministic you can still query on within certain limits. So we're just going to do that. Go next. And this is where it's really nice, because then we just say, oh, I want to use my Azure Key Vault. Great for that. Sign in, which every time. Bam, 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 bam. And it finds my Key Vault. So what this will now do is this database will connect to my Key Vault. It will create a whole bunch of master keys and all sorts of other magic and store them in Key Vault, and then it will encrypt the columns, and there's a whole bunch of key rotation and all sorts of other cryptographic stuff that we can talk about in the pub if anybody's interested. That will then happen automatically, which means keys roll over and change over time and all sorts of nice stuff. And that just happens for you automatically. Now, once you run this, so I'll show you on the other one that I have already done this on. So the nice thing is, once I've run that thing and I go to the database, here we go, and I select my customers because I am nosy and I want to see what they're all called. By the way, probably don't encrypt the name because you probably want to be able to search by the beginning of name, but see, that's actually what I get back. So that's the names of my customers in the database now. So your support team, they can go in there and they can query as much as they like, but they're not going to get very far because that's all the data that's there. Neat, eh? So now how do we get our application to still understand that data? That's the next thing. Okay, so we need to go to the next page of my notes. We have to add a service principal. So what you would normally use is use the managed service identity rather than creating another one, so I'm not going to show you that. And then we need to add them to the Key Vault, which is like what I did before you added that user into the Key Vault. So it's the same principle, they just need a few more permissions. Like they need to be able to unwrap and unwrap keys and a few other bits, but it's, just an instant of time, I'll save you from doing that. And then what you do, it's actually again fairly straightforward. You then, here we go. So we're going to use that one instead. DB demo, here we go. So I just got this is like the world's simplest my context here. That's anybody not using Entity Framework? No? Good, okay, so you all know Entity Framework, that's fine. So I basically have a very simple demo here that will just do a couple of things, and I'll just walk you through this. So I'm just starting this up with getting a base connection string, which I'm getting from config. Again, I should have gotten that from Key Vault, which if I'd been on my web app, but I'm not because .NET Core and all that. Every time it starts up at some point, I have to tell Entity Framework to use Key Vault to get encryption keys. And that way that code looks is, and this really threw me, by the way, I'll show you why. So this stuff here, the get key provider, I'll just walk you through this code. So the first thing I have to do is I have to get a key provider, which is basically an Azure Key Vault provider, and I give it a method to get an auth token. So this auth token here that I'm using here is, it looks very similar to that one we did before with managed service identity. In this case, I'm just reading the username and password out of a config file, but it's all you would do to make this work with Key Vault would be to change that get auth token method to use managed service identity instead of a username and password, which is what you obviously want to do if you do this for real. And then you have your key provider, and then, and this is the really weird thing. So you do this, create this provider dictionary, and then you call this static method on SQL connection that says register column encryption key store provider. And yeah, so what that basically means, once you've called that, then all subsequent SQL connections that gets made automatically gets enriched with all of the encryption keys and stuff from Key Vault. And yeah, honestly, I was looking at that in the documentation for literally half an hour, trying to figure out where is this wired up, and it turns out it's just a static method call. It's, yeah, I don't know, very weird to me. But anyway, the point is that once you've done that, all my other code is basically, I have to just, in my connection string, I have to set a, there's a value in my connection string I have to set that says column encryption enabled. So I'm doing that here using the connection string builder, but you can just put it directly in your connection string that you store. It doesn't really make any difference. And that's it. Then I just use it like I normally would. The only thing, there's a few limitations. One of them is this thing here. So if I put in, I don't know if you know this, but entity framework is a bit interesting because we know that it always parameterizes our values. That's only true if they're provided as variables. If I put in that constant string there into here, then entity framework will not parameterize that string because it says it's a constant, and it will inline it into the SQL statement. And if you do that, then you will get an exception because encryption can't work with inline constants. It can only work with parameters. So there's a few little limitations like that, but by and large, it works like how you would expect. So if I were to run that, then if we're very lucky, then let me just see, I've set this up right. If we're very lucky, it will then go and basically retrieve those customer names from the database and decrypt them on the fly without me having to write any decryption code. So fingers crossed. So I bought a new laptop. This is way too slow at compiling. It's supposed to arrive today. Thank God it's today. I'm really jealous. We ordered the same laptop. Come on. Oh, hang on. It's over here on the other screen. That's why. That's why you can't see it. That's silly, isn't it? There we go. So yes, it called down. It actually decrypted it on the fly. And the same thing, I can write stuff in exactly the same way. And it will encrypt it on the way up to the server. So I really like that. And it looks really scary when you start looking at it, and actually it's quite easy to set up. So you can do basically the same thing for blob storage. The code is very similar. In the interest of time, I won't show you now, but basically you set up pretty much the same thing. The code is going to be up on GitHub. And it means that for any blob you store into blob storage, you encrypt it client-side, and then it gets sent up to blob storage as an encrypted blob, and when you download it, it gets decrypted again transparently for you. It allows things like you can change keys over time, and any new blobs get encrypted with a new key, but it remembers the old key to use for all the old blobs. So every month you can change a new key, for example, and you just keep sort of doing that, and everything is encrypted for you nicely. And that's a very nice thing because, again, your support team might have legitimate access to blob storage, but you might have medical letters or all sorts of stuff in blob storage that you don't want them to read. You want them to see that it's there, but you don't want them to be able to retrieve it. And that's really helpful for a lot of the GDPR stuff and those kind of things, because this is where you're into your data loss prevention and those kind of things, where you're trying to limit who can have access to stuff. It basically means you can only read your blob through the application now. And that's pretty neat. Okay? Cool. Done that. Okay. So the final thing is, I don't know. So do you guys log in with your Microsoft Live IDs to Azure, or do you use Office 365 accounts, or who uses their Live IDs for Azure? Yeah. Who uses Office 365 accounts? That's a really good idea for starters, and you should definitely do that because it allows you to have 2FA, and you should have 2FA, so that anybody who logs into Azure uses 2FA. But you can also log into a SQL database with your Office 365 account. And that means you can have 2FA on your SQL logins. And that's something that's worth doing. So very briefly to show you that, and I know the pub is calling, what you do, and it's a bit weird to find it, but the first thing you have to do is to find your mouse. So what you do is a couple of things. Firstly, you go into your Azure Active Directory. Yes, I know, thank you. And you create a group. You don't have to create a group, but I would strongly recommend it. So in this case, I created one called SQL Owners, and I put myself in that security group. And then you go into your SQL server here. And It's the SQL Server, not the database, okay? Don't do what I do every single time and go look in the database. And you go and find, it's buried down here, Active Directory admin. You then set admin, and you find your group, select it, save it, and then what you then do, and I can't actually show this because there's some weird conflict with between my live account and my Office 365 account. But basically, when you log in here, connect, you can then select Active Directory Universal with MFA support. Log in with you just put in your username and password. I'll actually show you this file. I'll show you as far as it actually works, and then I'll stop where it breaks. But I do this, everybody in my office does this on a day. This is what we do with our day jobs. So basically it then pops up the normal login thing, and that will work with 2FA and all of that stuff. So now you have 2FA on your SQL login, and I think that's pretty cool. Just as it's a very nice security feature. And then, that you're all familiar with that dialogue there. Now, coming back to this, so that was great. I love that. I hate that when I then say, okay, that's great. So I now have complete DBO access to the database through my AD. But I got some other people I also want to give access, but I only want to give them read access. There's no UI in Azure for doing that. So if you're familiar with those kind of commands there, that's great. I'm not, and I have to go and Google them every single time. And every single time I meet with these Azure guys, I give them a hard time about this. For 2 years, I've been complaining about this, but hopefully we'll get it one of these days. So anyway, that's it. Works really well. So the from external provider basically says, that's what tells you to, this is not a local SQL user. It says, go and find that user over in AD and let them log into the database. Okay, so that's how we've set ours up now. So all our databases, nobody uses like SQL logins anymore. We all use Office 365 logins for Azure SQL. Okay. There are 2 tools you should look at in Azure if you haven't already. One is Security Center, and the other one is SQL Vulnerability Assessment. And there's a third one in preview, which is the SQL Data Classification tools. They're basically a bunch of tools, scans you can run on your databases and your Azure stuff to figure out where you have security vulnerabilities, where you might. And the classification one is a tool to basically go and look for fields that look like they have sensitive data in them and then ask you to classify them, and you can keep track. For GDPR purposes, it's a really, really powerful tool. So if you have any databases in Azure, just go and run it. It's free, and at least you can, because when auditors come in, it isn't just about whether you have sensitive data. They want to know that you are aware of it. So, and this tool will allow you to go and select next to each one what kind of data it is. Okay, so that's worth doing. That's it. Other than that, one of my absolute favorite tools of all time is Azure SQL Threat Detection. Has anybody used that? You have. Good. You have. So you switch it on. It is $15 a month per server, which is an insane pricing model because you can have one database or 100 databases in the server, because a server is just a label, but never mind. It is purely a commercial decision. They've done it that way. It has no technical basis whatsoever, because literally each database is its own server in Azure. It's pointless. But anyway, what it does is it basically it uses machine learning to analyze all the traffic that is flowing into Azure SQL database. And when it detects something that's a bit weird, it will email you and say, hang on a minute, somebody just logged in from this location. That's not normally happening. Can you go and have a look, please? It will also detect things like SQL injection. If you get anything that looks like it might be SQL injection, it will also email you and say, this is a bit weird. And it's really, I haven't got a demo of it, but I've had it a couple of times, and you literally get an email and says, hang on, this looks like SQL injection. You click on the link in the email, it opens up the portal, you do another click, and you have the SQL statement on screen saying, this is the suspicious SQL statement. That's how quick it is. It's honestly, if you have any data worth protected in Azure, that $15 a month is just well worth it. I would highly recommend that tool. The other thing is things like there's database auditing you can switch on. There's something called Intelligent Insights, which can log every single thing that happens in your database, and that's worth switching on so you have all of the records. And I don't know if you guys use Application Insights, but it's worth doing because it gives you quite a lot of information about the database. And in particular, this is into the detect thing. Things like you can feed Applications Insight into Log Analytics. Log Analytics is a massive logging platform, and you can basically collate all of your Azure logs and trace logs and everything into one place. So we have our serial log, all of our trace logs going into application insights, into log analytics, and our database logs, and our auditing, and everything else going into this one log thing. And then you can set up alerts and triggers and rules. So for example, you might say, so I know on one of my systems, on average, I have 70 failed passwords an hour. So I can set up a rule that says if there's more than 150 failed login attempts in an hour, send me an email, for example, because it might be somebody's trying to do it. Or if you're getting a lot of 404s and 403s, because if you're familiar with how people do scanning and privilege escalation attacks and that kind of stuff, you would tend to get lots of 404s and 403s in your log. So again, set up an alert on those kind of things based on what you have and those kind of things. And any non-app user access in the database, send you an email just so you know, those kind of things. So I said I wasn't going to demo those, so it was just sort of a pointer to those. I might do a separate talk on them one day. Okay. Oh, sorry, I'm 15 minutes over. I'm really sorry, guys. Any more information? Our company website there, we do some services around this. My blog and the code from this will be up on Security Talk. And I'm going to try, if this video works out, I'll try to stick it on Twitter, on YouTube as well. Thank you.